All right, M2-41. What we keep this passing out to you guys, a little bit of a warm up before we get into our lesson here on that page. You guys have done some. What we want to do here is jog your memories on some of the stuff that you should have done back in middle school, with what we call transformations, and how that's going to tie into as we look at lesson 3 today in this week. All right. So on there, question 1, as you can see on that little sheet of paper she just handed out. Take question 1. You've got yourself a triangle there. Go ahead and follow the directions of what they want you to do with that triangle. Don't overthink it. What do they want you to do with that triangle? It says translate it. 5 units left and 3 units up. So do that. Take the triangle, literally follow the directions, translate it. 5 units left and 3 units up. Where is that new triangle going to now be at? That's all I want you to do. Get a pencil. Push me, Angel. So these are what we call transformations. This is what we're about to do here with our linear work that you've been looking at. On our linear work, we've been graphing lines, we've been writing the equation line from the table, from the graph, from a word problem. And now what we're going to do is move these lines around based off what's being described here. So what you've done in middle school is the beginnings of transformations. And now we're going to bring it into our Algebra 1 class. So when you read the directions for number 1, when you follow it, 5 units left and 3 units up, take 1 point at a time and literally do what's being described. S, 5 units left. Do you know your left from your right? 1, 2, 3, 4, 5. 3 units up. And there is my new S. Take the T and do the same thing, right? Everything follows that same direction. 5 units left. 1, 2, 3, 4, 5. 1, 2, 3. And then take U. 1, 2, 3, 4, 5. 1, 2, 3. Connect it. And if you've done this correctly, take a step back. That triangle that you start off with should look exactly the same as the one that you just drew. If it's not, it means probably you can't count. Okay? 5 units left, 3 units up. Everything goes that same direction. Okay? Now, getting into a bit more work here, remember what you might have done in previous years. Okay? What we do here is give these new locations, we put like a little apostrophe up above there. In math, we call those primes. You say S prime, T prime, and U prime. What that tells us is that's the picture that we just created. We have what we call our math, our first figure that we worked with. We call that the pre-image. You do something to it, you transform it, and we get these primes in return, and we call that the image. So we drop the pre, and we call it the image. I'm doing that right now. I'm about to test it over with my geometry honors kids tomorrow. So this work will then continue on to geometry next year. So pre-image, pre-image starts it, do something to it, you get the image, and then how do I know the difference? These primes tell me, hey, this is the new picture. Okay. If you haven't done the next one yet, take the next one and go ahead and do that. Follow the directions on that next one. Translate that thing 6 units right, 2 units down. Keep saying a translation. A translation is left, right, up, and down. It's a slide. It goes left, right, up, and down, just like an elevator. All right, it's a slide. Everything goes that same direction, that same distance. So Make a point, do it. C, 6 right, 1, 2, 3, 4, 5, 6, and 2 down. 6 right, 1, 2, 3, 4, 5, 6, 2 down. And then, excuse me, letter D, 1, 2, 3, 4, 5, 6, 2 down. Connect it. If it's not the exact same shape and size, you've done something wrong, we are good to go. And then how do I know the difference between the image and the pre-image? The images get the primes. The pre-image does not get that. It's small parts of vocabulary. But as you roll into geometry next year, we're going to use that vocabulary. Okay. Now, let's take a look at the last one here. It doesn't say translate. It says dilate by a factor of 2. So I always ask my kids in geometry, when I say the word dilation, anything that comes to mind when you hear the word dilation? What's that? A dial? Say it over again. Getting bigger, thank you. I think of the eye doctor, and they put the drops in your eyes, and the pupil dilates, it gets larger, okay? It doesn't have to get larger, it can also get smaller, all right? We call that in geometry an enlargement or a reduction. So we want to take this one, and we're going to make it larger, because when we say dilate by a factor of 2, it means to double its size, okay? So how do we do that? All right, look at this picture here. Let's identify the coordinates for x. Where is x located? X is located at what? 1, 2. So once you know what the coordinates are, do the multiplication of that. Multiply both coordinates by whatever that factor is, in this case 2. So 1, 2 becomes now what, what? That's it, exactly it. What it's going to do is it's going to enlarge that triangle now by a factor of 2. So 1, 2 becomes 2, 4, 1, 2, and we call that x prime. Let's go do the next one. Where is w located? W is at what? 2, and then multiply it by 2. 2, -1 becomes what, what? Yeah, multiply everything by that 2. So 1, 2, 3, 4, 1, 2. And again, what should start happening is this triangle should start enlarging. And go to the last one. Where is y at? And then -1, -1 gets multiplied by 2. And where does y prime end up at? -2, -2. Connect it. And when you connect it, now that triangle, is it the same shape? Yes. Is it the same size? Definitely not. So in geometry that we've learned, I say we've learned, you should have learned that in the past, in middle school, right? And we'll talk about it again next year. These first two, same shape, same size. But a dilation does not preserve the size, okay? It's either going to get larger or it's going to reduce and be smaller, okay? But the shape should still be the same. And what we're going to do today in our algebra book in just a second is apply these rules, and we're going to take our linear functions and do something kind of similar to what we just did here. We're going to go up and down, left and right with some of these points here. Okay, so let's go ahead and do that. If you don't have your books again open, turn to page M2-41, everybody. I'll give everybody a second to get your lives situated again. Page M2-41. Let's go ahead and do the warm-up on that page, and then we'll move into our notes for today. Transformations is the name of the game. We're going to do that now. We're going to do that second semester. We're going to go backwards to talking about the absolute value function at the beginning of the year. We're going to do transformations, and we're going to take our exponential curve. We're we're going to do the same thing with it sometime in second semester with what we're talking about here today. It's not terribly difficult. If you're not paying attention, as always, it becomes way more difficult. But it's not a bad lesson at all here if we're coming back on Monday after things. Okay? So let's go ahead and start this off. Nice little warm up here of our evaluation of things. Number one is our old school stuff. Okay, but I want to talk really about 2, 3, and 4 with you here. It's a little bit different than what we've looked at. Nothing crazy though. All right, so let's do that. Whoops, wrong button. Stress again. Okay, when we say h of 3, we're taking our function. We go to our calculator, plug it in. I told you you didn't need your calculators out today. No big deal. I'll do the math for you. -2 times 3 gives me -6. And -6 minus 5 gives me a -11. Type it into your calculator. Boom, you're done. Okay. Now, we get to the ones that we really haven't talked about. I think they might have appeared in math yet. This number 2 here, and 3 and 4. I've got more to it than just h of 3. I've got this 2 times out in front as well. So how are we going to deal, say, with that? Well, go with what you know. You know how to evaluate h of 3. Don't you know how to evaluate h of -2? So let's do that. So we're going to take and plug that in again. You know how to do that. You know how to plug in -2. You know how to type that into your calculator. What do you get when you type that into your calculator? Okay. Well, what's -2 times -2 give me? 4. And what's 4 minus 5 give me? That's not my final answer, though. Because whatever you get for that answer, what do we need to do with it? Right there in front means, yeah, times it by 2. So it's just one extra now small step that we've been doing. We're adding on to it. Nothing crazy. So what is -1 times 2 give me? -2. That is my final answer then. So do what you know, and whatever you get for that answer, do one extra operations with that. So how about the next one? We're plugging in 1 this time, right? So we're going to type in -2 times 1 minus 5 into our calculator. You know how to do that. We've been hitting you guys left and right on that. When you type that into your calculator returns -7. Got a hanger just shut there. Okay. Now that you got -7, that's not my final answer because we need to do 2 other things with it. We need to multiply it by -1, and then we need to add 5 to it. Now, the order does matter what we do when. We just got, what, -7? And then plus 5. So what's -1 times -7? Plus 5. Yep. And then 7 plus 5 gives me 12. So my final answer here is then 12. Go with what you know how to do first, and then do the new extra stuff at the end here. Let's plug in that last one, the 0. So I keep doing that same thing. You guys know math. There's all that repetition that we've been hitting you with. Type that into your calculator. Shouldn't need your calculator, but if you do, type it in. And your calculator returns -5. That's not my answer I'm typing in, though. I now have to plug in -5 back here. And I'm going to go back to my calculator and tell my calculator now to do that one. Okay. Tell my calculator now what is 5 times -5 and then plus 5. Right. So -25 happens here, then your calculator does plus 5, and the final answer is -20. Okay. We're going to do some more work with that. Okay. But go with what you know how to do. You know how to do number 1. We've done that. Next one wasn't too crazy. Just now multiply by 2, or then add 1 to it if you need to. Okay? Because what's happening here is the transformations we just talked about on that warm-up as well. That little sheet of paper this kiddo passed out. You just did some of this work actually, but in a different sense. You took a graph and moved it around. You dilated it. You moved it left and right, up and down. Here we're going to do that same thing and talk about it not from a graphs perspective, but from an algebra perspective. So let's go ahead and do that. Let's flip the page here. Let's get into some transformations of things. So let's go ahead and flip it. Come on, Ryan, you good? Okay, saw you writing down there. All right, let's take this line that we got here. Segment, excuse me. Segment AB is given to us, and we're going to play around that segment AB just like we did on our notes here just a few minutes, that little sheet of paper a few minutes earlier. Okay, what we want to do then is what they tell us to do. Let's take it and move it up 4 units, and let's try to figure out a general rule of what we just did with that. So take AB, and let's move it up 4 units. Okay, don't overthink it. Move it up 4 units. So A and B, let's find where A and B is at. A is down here at what? -8, -8. Move it up 4 units. Don't overthink it. Take that line, move it up 4. And when I move that up 4, does that first -8 change at all? Does the x coordinate change? No. What did change though? The y coordinate, right? All we did was go up, and now we are at -8, comma, -4. Now, let's go with letter B up at the top there. Where is B located? B is up there at 8, 8, right? Now, when I move 8, 8, and I add 4 as well to that, is that x coordinate going to change? Is the first x of 8 going to change? No, we're just going up the elevator, right? Now we're going to go off the graph a bit. I don't know why they gave us that point. But let's go ahead and just go slightly off the graph. We're going to fudge it then. 1, 2, 3, 4. And where is that now located? 8, comma, 12. Take your ID and make that line. Okay? Give everybody a minute there to do that. I'm trying to think if they, yep. And they asked us to name this new one CD. So we're going to name this new one CD. Okay? Now, what we're going to try to do here is fill that table out with the rule that we just created. Now we went up 4. When you look at these points that we started off with and where we became, what we're trying to do is figure out a rule with anything. How does XY change? Did the X change at all? Stay the same. What happened to the Y value? Duh, it went up 4, right? So it makes sense it's going to increase by 4. So we're going to say then X stays the same and Y goes up 4 units because it says go up 4 units. Let's get crazy here. What do you think it's going to look like when we say go down 4 units? Is X going to stay the same? But what's going to happen to that Y value? Duh, it's going to go down 4, right? Don't overthink it. It's going to go down 4. So when they say go up and down, just literally do what's being told to you, and that's going to change only the Y coordinates. So let's go ahead and do that, and we're going to call that, is on the next page, what do they call it?
EF.
With an EF, thank you, Ms. Keno. So let's go ahead back to the original, AB, and let's move that down 4 units. Now, same thing happens down here. We're going down 4. We're going to call it EF. And when we go down 4, 1, 2, 3, 4, we go off the graph a bit. Whatever, we'll fudge it. And then AB, B becomes 8, 8. It's going to become, go down 4, 1, 2, 3, 4. And that's going to become what? 8, 4, correct. Take your ID, do a better job of drawing a line than I did. Take your ID. And as we said there, that X coordinate should stay the same. The Y coordinate is what's changing on us. Now, let's answer out a couple of these questions that are right here with us. It says compare the 2 segments and describe how they are related. So when we look at all three of these, can anybody give me some type of comparison there of what's still true between those three segments that are out there? X's are all the same. The size are all the same. They're all equal length. Anything else? They're all increasing. That didn't change, did it? Okay, they're continuous. Anything else? Yeah, what's the slope doing? We said it's positive. It's increasing. It's positive, right? Did it change at all? Are these lines ever going to intersect? No. So if we're not intersecting, what's the math word for that? We are parallel. So let's bring that together with everything you guys said. Okay. So let's see. We just said all are increasing because the slope is positive. I heard continuous. And the one that we were really trying to get to, as Ms. Keel pointed out, is that more in that slope. Slopes are the same, meaning the lines are parallel. And the reason why those lines are parallel is because the slopes are the same. So I always go Superman here with my arm. The Superman takes off. All right, he's flying through. He's got his arms parallel to one another. Okay, and it's because here the slopes are the same. All right, that's why those lines will never ever intersect up there. All right. Okay. Now, give us a second. We'll flip to the next page here because I think it still asks us to keep playing around with these lines. So, see somebody who's still writing. Go ahead and take a look at the next side there, next page there. Now I think it says it wants to change the y value. Doesn't it say multiply the y value by 2?
Yes.
And then it's going to ask you to multiply the y value by -2. So let's do that first one. We now want to go back. We're going to make this even messier now. Let's pick a orange here. Not that. Okay. Darn it. Let's try this again. Okay. Let's go back. Imagine, if you can, erasing everything and focus back on AB at 8, 8, and -8, 8. We want to multiply the y values by 2. Now here's the problem. We multiply these y values by 2. On AB we're focusing on. Well, what's 8 times 2? Are we on the graph at all? Even close to being on the graph? No. And if I do that down here, same thing happens, right? So let's go with a value that's a little bit easier, that's going to stay in the graph. Let's highlight this point right here for us. Let's highlight that point at 3, 3. Multiply that by 2. Multiply the y value by 2. It says multiply the y by 2. Y is 3, so 3 times 2 is, it's going to stay at 3, 6 right there. And let's do the same thing on the negative side of things. Let's do down there at -3, -3. Let's multiply that y value by 2. What's -3 times 2? And now let's connect our two new points. Take your ID, connect those two new points, draw a better line than I obviously am capable of doing. Try this again. Okay. And we're at -3, -6. What's that? Too many lines. I know. So, with that, what happens here? Did the slope stay the same this time? No. Did we become more steep or less steep? This is a harder line to walk up, but we say we are more steep then. Okay? And what happened was, because what do we do with that y value? We multiplied it, right? We didn't add or subtract it, we multiplied it. So what that's doing here is changing our steepness a little bit. let's get crazy and let's do one more here. Now they ask you to multiply by -2. I'm running out of good colors. Give me a second. Victor, we're going to do one more line here for you. Let's go with maroon. Okay, let's go back to that 3, 3 we did. We want to multiply the y value this time by -2. So let's do that. 3, 3. Where does 3, 3 now become? Multiply the y value by -2. It becomes what? 3 comma -6. All right, changed on us. And then we're going to go down here to that -3, -3. What's a -3 times a -2? +6. So we're going to be up here. Take your ID, connect it, and we are now at these locations, which, again, we are a hot mess going on. But what happened to that line this time? It's no longer increasing, is it? What are we doing? We are decreasing. So we are going from one to the other. And then math is we're going to go back to that page and kind of summarize what we just did here. What we say is we did a reflection. Okay? You know how a reflection does. Reflection kind of flips the orientation of things. And that's what we just did. So let me finally flip to that page and kind of summarize stuff that we just talked about. All right, so on that page, all right, compare the two line segments. So that first one we did, we multiplied by 2. We said the EF has a steeper slope, okay? It now had a steeper slope. So that was that EF, that yellow one I created. And then we multiplied by -2. And what did that do? It went from increasing to decreasing. And in geometry, what we call that, in math we call that a reflection. So let's say that. It went from increasing to decreasing, meaning a reflection. I'm going to get a little bit more specific here with you. Across the x-axis. So when you change from positive to negative or negative to positive like that, in math what we say that is, it's a reflection across the x-axis. So it was going up, we reflected it across the x-axis, we're now doing that. Okay. And then as you'll see next year in geometry, as you do more work with that, we'll do it this year as well, but not as much. Reflections happen, or changes that orientation, it flips it on yourself. Okay. So let's go ahead and talk about that. Let's flip it to the next page, I believe. And let's do a little bit more work here on that next page. Just put those phones away. And let's do a bit more work here. So what we were just doing is kind of summarized right here on this picture with these two tables. This graph here, here is the original graph, and what did they do? They went down. How many units did they go down? They went down how many? 1, 2, 3, 4, a little bit more. They went down 5 units. Okay, so this is where we're doing that x, and we're keeping the x the same, and what does this become? Y minus 5. -2 becomes -7, minus 5. -1 becomes -6, minus 5. 0 becomes -5, minus 5, and so on. So that's what's doing on that table. We kind of did that a few minutes ago. We wrote that all in the graph and made a nice mess. So let's take a look at that. On question 1, don't overthink this. We've been doing this stuff already. Identify the slope and y-intercept, and let's write the equation. So when we write the equation, everything goes back to ax plus b. Now this one here, we're calling mx. We have 2 graphs on there. One is called f of x, one is called m of x. Bless you. Make sure you are looking at the correct graph, because we are talking about multiple graphs now. So which graph am I talking about? M of x. What is the slope of this? I'm sorry? It is 1, right? And if you're not sure, make the stairs, right? Make the steps. How do you go up and over, up and over, up and over, up and over? How much should we keep doing? Up 1 over 1, up 1 over 1, up 1 over 1. And we keep doing that up 1, right 1. And we've hit you on that a lot here. That slope is still just 1. Where's that graph crossing the y-axis at? Where's my y-intercept? Right here at -5. Correct. Those are all things that we've been doing before. Now we're just looking at it for our transformations today. Okay? All right. Let's keep talking there. Anything else on that page? No. Give us a second. We'll flip it. Give you guys flip that. So don't ever think anything we've been doing. You guys are able to tell me we're going up or down. Cool. Making the equation. We've done that before. Let's look on the next page. All right. Let's take this next one. What do we want to do on this next one here? Translate it up 5 units. So take that graph, translate up 5 units, and then let's complete that table. Let's follow those points so that we can go up 5 units. So -2, -2. We start there, we go up 5. 1, 2, 3. If I could count. 1, 2, 3, 4, 5. And what is that new location going to be at? -2, comma 3. Which makes sense. We added 5. What's -2 plus 5? Yep, it is that. Okay. And then what do we have for the next one? -1, -1, go up 5. 1, 2, 3, 4, 5. We're at what? -1, 4. Take 0, 0, up 5. And then what? 1, 1, go up 5. All we're doing is taking that y value and adding 5 to it, right? And 2, 2 puts me at 2, 7. And you should be seeing it right here in that y column, where the original graph all got bumped up by 5 units. Okay. Take your ID if you didn't do so yet, and make that continuous line. Okay. Now, let's identify the slope and write the equation of it. Okay, let's identify the slope and write the equation. So just like we did a second ago, what is the slope of our transformed line? What's my steps doing? It's still doing 1 over 1, right? As we do my steps there, up 1, right 1, up 1, right, it's all staying the same. Right here on our original one, it all stayed the same as well. So when we write this thing out, what is this called? P of x? This guy is called P of x this time. As you can see right there, it's called P of x. Slope is 1. And where is it crossing the y-axis at this time? It's crossing the y-axis right here at the y-intercept at 5. So that's the equation of my transformed one. It took the original x and added 5 to it. We're keeping it simple today. Tomorrow we'll change it up a bit. All right, give me a second off that. All right, let's take a look at number 3. We've been doing number 3 over the last couple weeks. We want to go find f of 2 and p of 2. That means when x is 2, where is the y value at? We can see that in the graph. We can see that in the table. So when we say f of 2, all right, when f of 2, when x is 2, what's its output? 2. When x is 2, what's its output? Also 2. So right there, we're going to say f of 2 is 2. Now what is p of 2? Is it also 2? No, it should be the original up 5, right? And 2 plus 5 is, yep, 7. 2 comma 7, that's that p of x, 2 comma 7. Over here, this is our, I forgot to label it, p of x, 2 comma 7. So, how did it transform? Difference of how much? 5. Difference of 5 units. Which makes sense because they told us to go up 5 units. Okay. Don't overthink it. I know there's a lot of different types of, a lot of notation we're using, but just don't overthink that. Go with your instinct there. Up 5, what's it do? Down 5, what's it do? Okay. Use your slopes. We've been calculating slopes. Doing your steps. Nothing's crazy there. All right, how about this last, I think this will be our last one here. 2x minus 4, sorry, 2x minus 1, that's j of x. And what do they want us to do on this last one here? They want us to go up 4 units. So we'll take that graph, if you haven't done so yet, and go up 4 units. Find a couple nice points and move those points up 4 units. Take your ID and make the line. Where's a nice point to start off with? The y-intercept, right? Up how much we say? 4? 1, 2, 3, and 4. Find yourself another nice point on there. Use a different color to go with that. Okay. I'm going to take this nice point right here. 1 comma 1. All right. Now I'm going to go up 4. 1, 2, 3, and 4. Take another nice point. Find it. Okay. I'm going to go down here at what? -1, -3. And I'm going to go up 4 units. 1, 2, 3, 4. That's enough points there. Take your ID and make the line. And let's label that line J of X. Thank you. Nope, G of X. Or is it?
That's
Q of X. Q of X. I saw that earlier too. I thought G. We deal with numbers, not letters, right? Q of X.
Almost Monday.
Yeah, it's Monday after break. Now, let's get a little funkier for today. Once we kind of get through this last part here, we'll be done. But it doesn't say write it as function form. It doesn't say write it as ax plus b. It says write it in terms of j of x, which we have not done that before. Okay, so what does that mean? So on that letter A, when it says write it in terms of j of x, what do? Q of x, what do we do to j of x? We took it and moved it up how much? 4. So we took j of x and added 4 to it. So we've not done this before where they say write it in terms of another one. I say it sounds simple, I know it's not, but we're taking the one that they give us and doing whatever operation they told us to do. So plus 4, so we say j of x plus 4, that gave me q of x. Okay. Now, let's do that again, but this time they want you to go down 4 units. So let's go back up to my graph. Let's take it down 4. Let's take those points that I highlighted in red, and let's move it down 4 units. Okay, and then we'll do that same thing there, and we'll finish this off for today. Down 4, down 4. Take those red points that we highlighted and go down 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Take your ID, and as you make that line, those lines should all be parallel. They should not intersect. Okay, now mine is not nice and straight, but they should all be parallel, not intersecting, because all we're doing is going on an elevator, up and down. And we decided to go down 4, and they want us to call that last one, call this it R of X. We're going to call this one R of X. So what's that going to look like when I say write it in terms of J of X? Don't overthink that, exactly it. For our new dude, R of X, we took whatever the original was, and subtracted 4. Don't overthink that. Now, let's just again keep kind of throwing in some curveballs here to you. Letter C, we will now rewrite that. It says now just in terms of x. So when I want to write that in terms of x, that means I want to get rid of that j. I want to get rid of that j of x. I just want it to be x. So how the heck do we do that? Okay, go back at the very top of the problem. What did they tell you j of x equations was? It was what? 2x minus 1. So what we're going to do here is take q of x first. I think q of x is in blue. We're going to replace that 2x minus 1. And we're going to bring in our combining like skills, combining like terms skills. 2x minus 1, and then do a minus 4 to that. Where's your like terms at? 1 and 4, right? And what does that combine to give you? Negative 5. That is my equation, just in terms of x. Okay. Now, how can I check myself? What's the y-intercept here? The y-intercept is negative 5, right?
Q of x was plus 4, and then j of
Oh,
x.
I did the plus 4 minus, my bad.
Just change the color, or change
Yep.
the...
Ms. Keel pointed out Q of x is supposed to be what? The plus 4. And what did I accidentally write? My bad.
Which is the j of x.
Yeah. So right there, I should put a plus there. My bad. And negative 1 plus 4 is not negative 5. Negative 1 plus 4 is what? Plus 3. So as I was about to check myself up here to confirm that I did it right, I should have a y-intercept of 3 showing for that first line. And does that confirm on my graph up there? A y-intercept of 3 does look correct then. Thank you for pointing that out. Now, for the other one, we want to do r of x. And on the r of x, what do we say we did there? We did the minus 4, correct? So, when we do the r of x, we take the original, I can write a j, and this time we're going to subtract 4. So j of x, they told you, and we had done that a second ago. Combine like terms, and there we go. Okay, and I can confirm that if I look up above, minus 5, that should be my y-intercept, and it does check out. Okay, there's a lot going on there. All right, is it crazy difficult? No. New? Yes. So it might seem kind of challenging at the moment. If you do this stuff over the course this week, it becomes pretty a little bit more straightforward. Okay. Ms. Keel's going to pass out the assignment here for you. Give you all a minute, get situated, and we'll go over that, a couple of those things, and then have you finish it up. Okay. So, assignments coming out there. You can put your books off to the side. So today, this week, we're working on transformations, taking those lines and going up and down, and eventually we're going to do some more of the steepness of it. All right. Let's do a few of these homework problems like we usually do, just kind of get you set up on things, and then I'll let you guys finish up the rest of that period. Matthew, last week we opened up Unit 4, I think it was. I told you 5 and 6 are the last 2 for this semester. So 5 and 6 this week on Thursday we'll do the next Matthew day. Let's open up Matthew 5, and I think there's one more after that, which will be Unit 6, and then we're done for the semester. All right, let's take it to homework right there. 1 and 2 you guys come back to. Number 3 and 4, or sorry, number 3 right here. We just did this on the notes a few minutes ago. If you follow the directions to get you those lines, you should be fine. Now on letter A, let's do that one, and then I'll let you do B and C. We want to transform to create CD by doing what? 3 up and 3 right. So this time we have a movement left and right happening. So go find the point. Let's take CD here. And what do we want to do with CD? We want to take it 3 up and 3 right. So take C. go 3 up. 1, 2, 3, and then go 3 right. So 1, 2, stop drawing on the board. 1, 2, 3, 1, 2, 3. And we want to call that what? E. And let's go do the D the same way. 3 up and 3 right. 1, 2, 3, 1, 2, 3. Take your ID, and what should be true about these two lines again? Those two lines should be parallel. And what are the new coordinates then? What's the coordinates of E? Negative 1, 7. And what's the coordinate of F? And if I compare that to CD at the top, it should have changed by 3. 3 up and 3 to the right. That does check out. I went 3 to the right, that's a negative 1. I went 3 up, that's a 7. I went 3 to the right, 9. 3 up, does check out mathematically. Okay? I'll let you finish off B and C. That's the new stuff for today. And then what do we notice after that? Have we ever done that stuff before? Oh yeah. Let's look at number 5, letter C. Let's look at 5C here. 5C, this is where we want to kind of come back around and do some of our older stuff. We want to set that up to solve an equation. You're not going to plug that in for x. You're going to go off the side, put 23 is equal to negative 2x minus 5. And as we've been reviewing over the last month now, you want to use your equation skills to solve out for x. So, if it's helpful for you, I'll keep putting it down the middle. We want to solve out for x. What are we going to move first, the negative 2 or the negative 5? And the inverse of a minus 5? Yep. And whatever you do to one side, you got to do to the other. Watch your arithmetic. This is where our calculator is important. Check yourself. 28. Now the next silly mistake that I see a lot is adding 2. But between that negative 2 and x is multiplication. The inverse of multiplication is, so we're going to divide by negative 2. And then check yourself in the calculator. 28 divided by negative 2 is negative 14. Now you're going to do the same thing on letter D. I'll let you finish that one off. But on letter D, you're going to create the same equation but negative 13. I want you to use your equation skills just like we did to finish off solving for x then. Number 4, we've done a crap ton on. Let's flip it. Run it across. This is nice review for our finals coming up. You should be able to look at A, B, and C really quick and tell me what do we have, linear or nonlinear equations. Well, again, when we say linear, linear means ax plus b, x to the first, x to the first. There's nothing else happening to that x there. So run it across real quick, yes or linear or nonlinear. Is letter A a linear or nonlinear? Definitely is. X to the first, that's linear. Is letter B a linear or nonlinear? No. What's screwing that one up? Yeah, x squared. What do we call that from the beginning of the year? X squared is called a... That's my quadratic. Okay. We're reviewing it now to get you on the final here. Quadratics, remember, are U-shaped. And the last one, linear or nonlinear. And what is this one code for? Well, it has the absolute value bars, so as Ari said there, it is the absolute value. And what's that shape? Yeah, V for value. Those are my two graphs. On the final, we'll kind of come back around and talk about those. And then second semester, we're going to talk about absolute value a lot more. Okay? All right. Then, as you see there, are word problems. Have we done word problems lately? Sure have. Okay? So let's take a look at number 8. All right, read through there. We've sold what? We've sold hot chocolate. We've sold cake pops. We've sold shirts. We've sold sweatshirts. popcorn, pretzels. Now we're selling what? Peppermint hot chocolate. So let's do that. All right, what are we letting things represent here? C is representing what? Yeah, we're selling cups of hot chocolate, right? So C is representing the number of cups. Now, what is that E of C we keep talking about representing?
Earnings.
We gotta make money here, and the E of C is right, the earnings. So if you want to run a business, you got your earnings coming. And how are those earnings coming? What are we selling on that? $3 each, right? One cup gets you $3. 2 cups gets you $6. Do we have anything else to have to worry about? Yeah, we're also giving away some freebies, so we have to account for that. Now I heard a minus 10. Is that actually minus 10? Right, because how much is each cup of hot chocolate? So we're not losing $10. We're you losing $3 for every cup. 10 cups means correct. So you better count for that. If you say you're losing $10, in reality you're losing 30. And at the end of the day, when you go count it out, you're going to be off by a decent amount there. Okay. All right, let's go label these out now on our axes as we've done before. You've got your independent, the dependent variables already labeled. C and E of C, where are these two going on our X and Y axis? Okay. So the X axis, is that the earnings or is that the cups? That's the cups. That's the independent. That's the domain. So this is going to be the number of cups. And what do you get in return? You get the earnings as your Y values. Okay, and what are we in? We are in dollars, right? So it's always the case. The X, the C, that is your independent, that is your X axis. And then the money, the earnings, that's your Y axis. Now, how much money do we make with 16 cups of hot chocolate sold? So look at that graph. We just kind of did that earlier. We've done it the last couple of weeks. If you sold 16 cups of hot chocolate, how much money did you make? Where are we at that? 16 cups. 16 cups, where's my graph at? Right here, right? So how much money did we make? 16 comma what? Where's that point located? I highlighted. 16 comma 12. So what does that mean? I only made how much? I only made $12. Doesn't seem like a lot because why? How much coffee? How much hot chocolate do we give away? $30. So we got to recoup all that money first, and 16 cups is only getting you $12. So it's going to take a little bit of time to recoup that money. All right. Now what else we got there? Is there any more questions? Off to the side then. How about 125? You sold 125 cups of hot chocolate. How much money did you make? Can you look at the graph? Is on the x-axis 125 visible? No, we stop at 16, right? 125 is all the way over there. So how do we figure that out? You use your equation that we created. If you can look off the graph, great. But if you can't look at the graph, use your calculator. Use the equation. 3 times 125 cups sold minus 30. Go to your calculator. This is why we've been practicing all that evaluation when it comes into play here. 3 times 125 means I got $375, but how much did I give away? Got to account for that. So I'm not making $375. I only made $345. That will always be true. Okay. Now, there's that word break even I keep talking to you about the last week or so. Break even means you get out of the negatives, you're at 0. You're not making money yet, but you at least are out of the red. So how many cups does it take to get out of the red here? Okay, we're giving away 10 cups, right? So to get out of the red, we need to sell 10, right? All right. And then after that, how many cups were purchased? Cups of, keep saying coffee. How many cups of hot chocolate purchased if we raised $300? So now we're going to go back and use our equation skills and solve this out. So I keep stressing you got to have basic equation skills coming into us. All right, we got a 3 and a 30, a minus 30. What are we going to do first, a 3 or a 30? Yep, and it's a minus 30, so the inverse of a minus 30. And got to do it to both sides. 300 plus 30. And then, as we've been seeing, if you've been paying any sort of attention, we keep having multiplication. And the inverse of multiplication is, go to your calculator, 330 divided by 3. There we go. 110 cups of coffee. Peppermint hot chocolate, right? Makes a big difference there. I do like peppermint hot chocolate. So does Mrs. Trish. And she's happy. Sometimes not. All right. Don't tell Mrs. Trish that. All right. Last one there. We've hit you on number 9. I'm not going to do it. You're going to do it. So you've got yourself about 20 minutes. Let's finish this off. If you're stuck on something, give us a holler. Tomorrow, we'll continue working on things. Let's get ready to rock and roll here. Okay? It's Monday back. I know that. It's a little rough, but let's use this time.